The overall goal of this procedure is to assess the anchorage and stability of newly formed reparative bone to candidate implant surfaces. This is accomplished by first creating two groups of custom titanium implants. One group treated with a standard grit blast treatment to create an underlying microtopography, and a second group with the same grit blasting treatment, as well as superimposed calcium phosphate nanocrystals. The second step is to place implants into the distal femur of male Wistar rats for 9 days, at which point femora are collected. Next, the femora are cleaned, and the surrounding bone is trimmed to the width of the implant, leaving mechanical testing specimens with the cortical arch on either side of the implant. The final step is to put the test specimens in a flowable dental composite using a custom breakaway mold, which isolates 0.5 millimeters of peri-implant bone, and to conduct mechanical testing on the specimens. Ultimately, mechanical testing results provide an assessment of the ability of the candidate implant surface to act as an anchorage surface for newly formed reparative bone.
This method can be employed to demonstrate the importance of different scale ranges of implant surface topography on the various mechanisms of bone anchorage, from bone bonding at the nanometer scale to bone ingrowth at the coarse micron scale.
The technique is particularly suited to measuring the effects of candidate surface designs, such as anchored surfaces for newly formed reparative bone, since it limits the mechanical testing region to within 0.5 millimeter of the implant surface.
This method can provide insight into the effects on bone formation.